Hi, my name is Stephanie Crabtree. I'm from Prepped and Polished Tutoring, and today I want to teach about matrix math on the ACT. You may have encountered your first matrix problem on an ACT practice test, or maybe on the ACT itself, and you may have wondered, when did I ever see this in math class? Maybe you did see it in math class, but you don't remember how to do it, or maybe you even just need a refresher. Well, today we're going to talk about what you need to know about matrices on the ACT. Matrices are a little scary for any student, especially if you don't remember how to work with them. You just have to remember that matrices are like algebra in disguise. There's no new information that you haven't learned yet. Alright, we all know what a system of equations looks like. I'm going to write one on the board. This is a standard system of equations. You've learned how to deal with this in your algebra class. And you know how to substitute in an x and a y into the other equation to solve for one and then solve for the other. Now you may have wondered, even with just a simple set of two equations, is there an easier way to solve for one of these variables or both variables? Say, for example, we had an x coefficient in a table. We had a y coefficient. We had the resultant here. And we have equation 1. We're going to call this equation 1, and we're going to call this equation 2. So let's make our table. So here we're going to put 2 as the x coefficient. We're going to put 1 here because there's a 1 in front of that y. And we're going to put 3 as our resultant. Same thing on the next equation. 7 is our x coefficient, 2 for y, and 5 for the result. Now, mathematicians like to simplify things as much as possible. So what if we could just take this table itself and work with it and not have to worry about substituting back and forth? Well, there is a way to do that. It's called a matrix. What if we have 2, 1, and 3 from this top row, and we have 7, 2, and 5 from the second row? This is all a matrix is. It's simply a system of equations with coefficients and resultants from the equations. Now that you have your matrix with your resultants and your coefficients, you could solve for one of the variables or both variables, but we're not going to do that today. That's outside of the scope of this video, and it's outside of the scope of the ACT. You don't have to worry about that section. What we are going to learn today is how to add and multiply, and we're going to learn a little bit about comparing elements in a matrix. So just some terminology. We're going to have a row here and here. These are the horizontal components. This is a column here, here, and here. And one piece or one number in the matrix is called an element. This 1 here is an element, this 5 here is an element, etc. Now that we have some terminology down, let's talk about addition. Here's our matrix. Can we add another matrix to it? And what does that mean? So let's start with this matrix here. We can add a matrix element by element. And what that would look like is another matrix of the same form with each element added to the others. So 2 plus 4, 6, 1 plus 2, 3, etc. We end up with this resultant matrix. Now you may be wondering, sure, I get what that does mathematically, but what does that mean? It's like this. Remember, this is just a set of equations. 2x plus 1y equals 3, and 7x plus 2y equals 5. What do those each look like? Those are lines. So if we add a line and a line, and a line and a line, we have our original line characterized by this, and we have another line characterized by this. For example, those are not the lines I drew, but imagine that these are the two lines we have. You add those together, point by point, and you end up with one line. That is what it means to add the elements in a matrix. You're adding two lines, you're putting them together. All right, now that we have addition down, let's talk about multiplication of matrices. This may seem a bit more difficult, but remember, you are just working with lines. So we have another matrix here. This is again an XY and a resultant matrix. And we have another matrix of a different form right here. One thing to note about multiplying matrices is that the number of columns of the first matrix, let's call it A, has to equal the number of rows of the second matrix, let's call it B. So we have 3 columns here in the first matrix and 3 rows in the second matrix. You'll see why that's important in a second. Another thing to note is that you can't change the order of the matrices. So this has to go in front of this. And sometimes on the ACT, they will switch the order and ask you if it's all right, and it is not, and you'll see why in just a second. All right, so let's do the actual multiplication. We're going to write out every single step so you can see how this works. First of all, you take the first row, and I have this marked by my 3 fingers here, and you multiply against the first column in the second matrix, and you add those elements together. So what does that look like? We have 2 times 1, so it's 2. We're going to add the second one, because remember, we're going like this. 1 times 2 is 2. 7 times 8, 56. Okay, so now we take the first row and we multiply by the second column. And I'll explain a little bit more in a second. Stick with me here. 2 times 5, 10. 3 minus 7. And then we take the second row and we do the same sort of process. We multiply by the first column. 4 minus 6 minus 24. And then we take that second row again and we multiply by the second column. 20, 9, 1. We're going to go ahead and simplify to get our resultant matrix. 60, then 13 minus 7, and then negative 2 minus 24, and then 11 plus 1. This is our final matrix. Another way to think about this, if you forget which columns have to go with which rows, remember, these columns had to go with these rows. So you can think of it like this. If you have the first matrix on the side and the second matrix on the top. So it goes over times down. And then we have another over times down. So this over times the down. And then again, we take this one times down and this one times down. Essentially, what you're doing is you're putting this number of rows times this number of columns. And that way you get a 2 by a 2 matrix. There's a lot of math here that you may not have encountered before. With a little practice, you'll be able to do it quickly and you'll be able to reason through some of the problems on the ACT. This video was about all the fundamental basics you'll need for the ACT. The next video, we're going to talk about some concrete examples of what you're going to encounter. I want you to remember, this is just algebra. There's nothing difficult that you haven't seen before. It's just a different way of summarizing the information. If you liked what you saw, subscribe to our channel. I'll see you in part 2.